Introduction to Functions as Objects in Python. Hello everyone. Today, we're diving into an essential and powerful concept in Python, functions as objects. This topic might feel a bit abstract for beginners, but it is one of the core features that make Python such a flexible and powerful programming language. Through this discussion, I hope you'll grasp this concept and learn how to leverage it effectively in your programs. What are first-class objects? Let's start by understanding what first-class objects mean. In Python, functions are treated as first-class objects. This means they can be used just like other data types, e.g. integers, strings, lists. Specifically, functions can 1. Be assigned to variables. 2. Be passed as arguments to other functions. 3. Be returned from functions. 4. Be stored in data structures. We'll explore these properties step by step with 4 examples. Example 1. Assigning functions to variables. Let's begin with the first example, assigning a function to a variable. Code explanation. 1. We define a function greet that takes a parameter name and prints a greeting. 2. We assign the function greet to a variable my_function. Note, there are no parentheses in the assignment because we're assigning the function object itself, not executing it. 3. Finally, we call the function using my_function, achieving the same effect as calling greet directly. Key takeaways. Functions can be assigned to variables just like any other object. The assigned variable retains all the functionalities of the original function. A function's name is essentially a reference to the function object. Example 2. Functions as arguments. Next, we'll see how functions can be passed as arguments to other functions. Code explanation. 1. We define a function apply_function that takes 2 arguments, a function func and a value. Inside apply_function, the passed-in function is executed, and its result is returned. 2. We define another simple function square that calculates the square of a number. 3. Finally, we pass the square function as an argument to apply_function along with the value 5. The result is 25. Key takeaways. Functions can be passed as arguments to other functions. This technique is commonly used in designing callback functions. It enhances code flexibility and reusability. Example 3. Returning functions. The third example demonstrates how a function can return another function. Code explanation. 1. We define an outer function make_adder that takes a parameter x2. Inside make_adder, we define an inner function adder that takes another parameter y and returns the result of x plus y3. The outer function returns the inner function object adder. 4. When we call make_adder 5, it creates a specialized function that adds 5 to any given number. We assign this function to the variable add_5. 5. Using add_5, we compute 5 plus 3 and 5 plus 5. Key takeaways. Functions can return other functions. This technique allows for creating customized functions. It is widely used in factory patterns and closures. Example 4. Storing functions in data structures. The final example demonstrates storing functions in data structures like lists or dictionaries. Code explanation. 1. We define 2 functions, greet and farewell. 2. We store these functions in a list called functions. 3. Using a for loop, we iterate through the list and execute each function, passing the argument xiaoming. Key takeaways. Functions can be stored in lists, dictionaries, and other data structures. This allows for batch processing of multiple functions. It is useful for implementing the strategy pattern. Summary: the power of functions as objects. Through these 4 examples, we've seen the powerful features of treating functions as objects. 1. Flexibility. Functions can be manipulated like any other data type. 2. Modularity promotes code reuse and organization. 3. Abstraction enables higher-level programming abstractions. 4. Design patterns supports implementing advanced design patterns. These properties make Python an excellent language for rapid development and creative design. Reflection and next steps. Before we wrap up, here are some points for you to think about. 1. Do you have any questions about the concept of functions as objects? 2. Can you think of ways to apply these techniques in your own projects? If you're interested, we can delve deeper into related topics like closures, decorators, and functional programming in future discussions. Don't forget to subscribe and share so you won't miss these advanced topics. Thank you for joining. If you have any questions, feel free to ask or discuss. I hope today's session has helped you better understand the concept of functions as objects in Python.